My name is Dat. I'm a solutions architect here at Arise. I work very deeply alongside our customers, building, coding, architecting with them on their kind of LLM applications. So background in data science and a little bit of software engineering, but I'll let my partner, Varna, introduce herself.
Awesome. Hey, everyone. Thanks for joining us. My name's Aparna. I'm one of the founders here at Arise and I run product. I'm actually really, really excited for today's webinar. I think it's going to be a really awesome one on router-based architectures, what we're seeing out there, seeing some of the teams we're working with and what's going on in the ecosystem doing. And I think we'll chat through a little bit of like how, how we're seeing evaluations also shape up for them. So, Dad, should we give it another minute or maybe just
Yeah,
jump in?
we'll give it another minute, and then we'll wait for folks to maybe hop in. But while we're waiting, I'll do a quick plug. So July 11th is our Arise Observe event. This is an in-person event here in San Francisco, in the Ferry Building. So if you've never been to the Shack 15 space in the Ferry Building, it's a beautiful, wonderful space. We're gonna have some pretty amazing speakers, everyone from Mistral to kind of I think Google, Microsoft, all the kind of the bigger players in the LLM space. And so here's the kind of a free promo code too. If you're looking to get your ticket, it's Evals 200. You can always use this QR code to kind of log in. And then we also have, the link will be posted not only in the chat, but probably in the YouTube comments, the description section. So just wanted to quickly highlight that our Observe event is really a place to really share kind of what, to meet really great speakers, to share kind of, there's different branches from researchers to, builders to even maybe what are kind of the latest companies kind of up to. But Parna, I don't know if you want to give a plug on maybe Observe or anything else you want to add.
Yeah, I want to say there's a couple different tracks at Observe. So if you're interested more on the research side, we have people like Gorilla LLM from Berkeley is presenting on kind of function calling and all the research they've been doing there. There's Meta's presenting at some of the research they've done. So there's kind of like a research track. Folks are presenting on research. There's a developers track. So you'll hear from the open source community, and then you'll also hear from actual industry use cases of LLM. So we've got a little something for everyone and a wide spread of speakers. So hopefully you check it out.
Awesome. Thanks, Parna. All right, let's kind of dive into it. So, what's the agenda for today? So what we're going to cover is really, we're going to go to a little bit of background on like routers and why we're kind of at this state. Agents have a little bit to do with the kind of this story, but we're going to go into a little bit of that. And then we're really going to go in depth. What is a router architecture? What does it mean? What are the different parts, like the router function or what execution branches look like? We'll go into the different components of a router, how they work, what they tend to do. And then we'll talk about the evals for each one of these as well. As you'll notice in a complex architecture, you'll have many different, you can think complexities. Each component might be evaluated maybe a little differently. And so we'll go into component level evals. We'll also go end-to-end evals as well. So what does it look like to measure this system from start to finish? And then lastly, we'll go into some advanced topics like router architectures, advanced router architectures that we're seeing in the enterprise. So if you're building in this space, definitely don't want to miss it. So big picture. Um, let's maybe talk about LLMs. And so, LLMs represent a significant step towards AGI, if you will. Probably making them one of the most important inventions since maybe the internet, I would say. That's my take. So maybe, as an example, two of maybe the most impactful applications that come to mind might be, in terms of productivity, those products might be like ChatGPT or kind of equivalents, or maybe Copilot and also equivalents. ChatGPT kind of serves as maybe an AI chatbot for general use, while GitHub Copilot might serve as kind of a code autocomplete tool. But however, while these applications are really great, they have their limitations, especially when it comes to handling complex tasks, maybe over extended periods of time. So, right, like you can't just tell ChatGPT or Copilot to, for example, build a somewhat complex application, test it, deploy it, and you know, just know that everything's going to be okay. We're not quite there yet in terms of these capabilities. My take is I hope we will get there, and it might be sooner rather than later. But today we just aren't there yet. So, agents are an attempt to kind of get around this. They are, you can think software systems that maybe string together LLM calls to accomplish maybe some sort of complex task. Agents use kind of, software to orchestrate these LLMs, enabling to perform and plan. And there's a lot of parts to these kind of agents. But what's really fascinating is that many parts of these kind of agent architectures actually like mirror cognitive models. If you're familiar with like SOAR or ATCR, these cognitive models, they similar to like a brain, but in the LLM world, these things might include like creating a task agenda or planning or long-term memory or information retrieval in the form of RAG and other advanced components. And it's really remarkable that kind of developers have kind of on accident kind of built this in LLM form. So agents are really, that was the promise of agents. There's a lot of really great, frameworks out there today. It's a super heavily researched area in the space. But maybe what are we saying? So, despite advancements, and my take is that they're not there yet, but I really hope they do get there very, very soon. They're not fully effective in the way that we think they work. They're not really fully autonomous, or they need a lot of guidance. So, for instance, we still lack, there's no software agent yet that can just autonomously handle, building in a repository, implementing a change on a high level instruction, and then produce something that's like PR ready within an hour, right? Um, and so, what are the major issues that we see with agents? And some of them are really that like long-term planning is really hard. I think it's hard for humans. There's things like complexity, dependencies, um, dynamic environments, how to deal with like, resource allocating, things like that. If you think about just planning is hard, then decomposing specifically hard problems is also difficult. Like if you imagine breaking down a problem, humans are also bad at this. Some are. And so having something fully autonomous do this, you can clearly see why it might be not so easy to do. If you've ever ran an agent and you've ever gotten stuck in a loop, it's maybe where a loop is where you keep looping through a problem and maybe doing this kind of reflection pattern until you kind of make it through. Sometimes you don't always make it through. That's just an example of where these things can kind of get stuck. Um, with autonomous agents too, I think personally the solution space can be too big. Sometimes you're trying to solve this kind of big, massive task without a lot of constraints or bounding the problem, and that can be very difficult for something like an autonomous agent to do. Again, we can go through the list: inconsistent results, unreliable. If you run the same agent twice on the same problem, you might not get the same output. Um, Another point is they can actually be quite expensive to run. If you imagine running through a loop and there's like a lot of back and forth and you're still not getting anywhere, costs can kind of run kind of high. Um, Again, these are complex tasks, and sometimes agents kind of take a tangent, if you will. And so sometimes they need to be corrected if they kind of deviate from the path. There's also other things that we normally deal with on a day-to-day, like data quality issues, etc. And so, I mean, you can traverse X or Reddit or Hacker News. There's some definitely opinions on the internet about agents. So, with that being said, I do think there is a space for agents. I think the research going into them super key. So it's not kind of an if, but maybe when. But just wanted to highlight and educate maybe the problems we see today with them.
And I think there's still a lot of people building on top of it. So it's gonna get better. I think we're all excited for when it does. But um I think some of these as we're seeing folks trying to put slightly more complex applications, like I want a user to talk to a chatbot and then either go and guide it down a path to multiple paths of either purchasing or getting returns. Um, it just requires many, many turns in that in that complex task. And so This is actually where, and this is kind of a little bit of preface for why we're talking about routers, is we're actually seeing people use routers. I've been thinking about them as almost like V0 agents. It's like a way for people to do these more complex execution branches using routers.
Yeah, really good point. And that's a good transition into the shift. So, knowing the issues that we just talked about, what is it that you need to understand to really build the thing that you want in the enterprise? And if these are the problems on the left, right? How do we shift into the what we want and what we need to build? Well, if the solution space is too big, maybe we map the solution space beforehand. Maybe we know the problem that we're dealing with and need to add, our own heuristics or our own systems or how our systems work in kind of context to this kind of application. Maybe we want to be very explicit on the actions and intentions based off of whatever conditions we understand, right? Um, and we want to be able to create a repeatable process, right? If you're creating a LLM kind of agent, if you will, or application to serve your customers, you hope that your customer gets a very consistent experience. And then the last thing is like maybe when it comes to orchestration, rather than if we know the plan, right? Maybe instead of having an LLM plan for us, which might be a little bit more non-deterministic than we want, maybe we orchestrate with code in more reliable methods than just using an LLM. So what does this end up getting us? What actually gets us into the router architecture, which a partner will take us into.
Awesome. So let's maybe start with a simple example and then we'll get into some of the more complex ones. So this is one where there's a user, could be a chatbot on a website. They're asking for, in this case, they're looking for a new Kindle e-reader for a reading hobby. So you can just imagine this could be any large, e-commerce store. And they're asking, are there any discounts currently? And in this case, when the user puts in an input, there's first kind of like this approach where you need to determine what is the intent of the user. Are they immediately looking for product recommendations? Are they looking to go, do they have a complaint? Like what are they actually here for? And so this first call that you're seeing here, which is kind of the OpenAI call, could be any LLM, but it's making a call to an LLM where it's actually determining the customer intent. Determines a customer intent. In this case, it's more of a, I guess, query. It could also be a purchase, but it's more of a query about asking, well, within specifically the Kindle readers that you have, are there any that currently have some kind of discounts or sales going on? And so it picks a path in this case of, okay, they're not immediately asking for product recommendations or et cetera. They're asking more for maybe the query path. It'll go down, decide what the intent is, and then go through an execution branch where it's determining, okay, I'm going to make a call to maybe the Q&A kind of a little bit more on the product search side. So product search or product discount search kind of function call. Make that call and then pass that response actually back to the user. And so in this very simple diagram, there's first determining intent, and then next is doing the actions after determining that intent that's actually happening. Some of these might be LLM components. Some of these might be actually application or code components that are happening. But there's kind of this, what path does the user want to go down? That first needs to be figured out. And that's kind of the core part we're going to get into, which is really consistent across the router architecture. These can get a lot more complex, thanks to that. So what we're seeing, in the ecosystem is that there might be, multiple. We're talking tens of different kinds of branches out there where there's a router function that determines the user intent. Perfect. And then there might be all sorts of different execution branches of, are they asking to compare two different products in this case? Are they searching across different products? Are they asking directly for customer support, go get me help? Are they doing some kind of returns, package tracking, or looking for discounts and deals? And so in this case, there's kind of 5 different branches that a person can go through. And each one of these might have its own different set of components to execute that. So if you're doing something like a customer support, well, you first might want to pass it through understand what the user question is, go look over your existing support documentation. If you can give a response, give a response. Otherwise, if you don't have anything, then actually kick them off to a live support agent. Within even this simple flow, you can see that some of those components could be LLM calls. Some of them is just pure application code. Some of those could actually even be calling out to your own internal models. So it can get complex. There can be multiple branches. These branches might not all be LLMs. Some could be internal API calls. Some could be ML calls. But the key thing you'll see that's connecting all of these is that router function at the very beginning, which is determining what is that user intent, and then that kicks off kind of all of these paths. Next slide. Dat, you want to cover this one? Oh, sorry. I think there's, oh, sorry, you're doing the one after. Okay. So let's talk first, what is a router function? Since we're kind of, this is essential to the topic today. So the router function's main purpose here is determining what path should actually be taken. It's typically the main entry point right after the user input. And there's a couple different types of actually router approaches that we'll get into in a couple slides of how we're seeing people do this in the ecosystem. It could be you're actually using a function call to determine the intent and go make that action afterward. Or you could just be using more of a classification type of call using an LLM to do this. It could even be a more simple NLP type of classifier. So there's kind of a wide range of what we're seeing these router functions look like. But the key goal is they need to set you on the right path. Because if a user asks for customer support and then you're recommending products to them, that's the first way to lose a user in your product experience. Next slide.
Awesome. And then one caveat here, just for education perspective, for those who are very familiar with the space, I just want to make a quick clarification. We're talking about router architectures, but there's also another concept in the LLM space. It's been kind of more of a recent one, but it's called LLM model routing. And now these are very different concepts. So I just want to explain what we're talking about is very different than this thing. But basically what LLM model routing is really, it's a very actually this interface pattern that we're seeing. If you are an enterprise that has multiple model providers, for instance, whether you're using OpenAI or maybe you have an internal model set, but a lot of people are exploring different models. LLM model routing is another different concept that really says like, hey, I'm going to actually call this specific model, due to it's either you care about load balancing or requests. You care about, hey, costs. So some models cost less or more than others. Some have different performance. So just wanted to quickly highlight that this router architecture is not the same concept as LLM model routing, but the model routing is kind of like, it feels very similar to like an interface pattern where there's this central spot where you can go and it has the logic to know what model to call, and really you just modularize the models kind of here. You can kind of pick and choose who your providers are. So just wanted to quickly highlight that what we're talking about is a little different than this, but you may have heard of LLM model routing, another concept that we might cover at a different time.
Yeah, and this one, just the key, if you go back to that one slide, yeah, this one, the key reason we often see this is sometimes it's cost. They want to make sure, or they're load balancing, let's say, but like these types of questions I'm going to send here. These are more complex questions. I'm going to send it to maybe GPT-4. This one could be GPT-3.5. Something like, especially with evals, we're seeing people do evals for a separate, model, but then their application code in a separate foundational model. So different, but just what we're not talking about today is model routing. Okay, back to what we are talking about.
Yep. And then one other thing, yeah, these are just examples of maybe products that are out in market, but also we've seen some people build their own. So
Yep. Okay, so the router that we're talking about, which is determining which intent or which path to go down, there's a couple different approaches that we're seeing in market. One is the approach where the router is actually using function calling. And this is where the function calling is actually determining what is the intent. And it's also actually executing the entire skill or the execution branch. And so in this case, it's doing call it both generation and skills together. It's generating what the intent is. So in the example before, for instance, if you go back to maybe the slide 9 dat, in the first path, router using function calling, it would actually determine the user intent. If you could just hover on that, yeah, it would determine that user intent, and it would kick off the call to actually go and do, let's say, customer support or do, whatever. There's another approach, which is slightly, it breaks it down into two different steps, which is router, which uses, it's slightly more LLM intent classification. So in this case, you're not actually using function calling. You're using the router to first figure out what the intent is. So I want to go do this. And then you can actually, you could do it in a couple different ways. You could still do function calling after that, or you can actually use code if it's slightly more deterministic, et cetera. If you want to actually just then go and execute down a path, you could kind of do that path as well. And there's pros and cons to both. So with function calling, what you're going to get is, what's great is you might be able to parallelize calls. So if you have multiple skills you want to kick off at once, if you want to, use the state of multiple skills and come back with an even, more complex response. There's all sorts of things you could do to be able to parallelize and do skills together. It's going to be lower latency. And then you can also do different function permutations. So you might not even need to call, okay, I'm just going to call the customer support API. You might just extract what the intent is, but then decide, hey, I actually think what the user is really getting at is something else, and I'm going to go call a separate path here. And so there's slightly more, I think this is going to be the slightly more modern approach that we start seeing more and more. But we are also seeing a decent chunk of folks in the ecosystem do this like intent classification, like break it down, basically, do the intent classification first, and then kind of kick off that entire execution branch. This approach has kind of the advantages that you can intermix basically heuristics, so more deterministic code kind of approaches with an LLM classification for routing. So you can kind of combine code and an LLM together. I'm going to take one question from the chat. So Lay asked, how does the router deal with new intents? The intents are not defined before. That's a really great question, Lay. I think, so we're seeing a couple different things, I'd say, in the ecosystem. Some people have a path, which is like your catch-all path, and the catch-all path takes you to something like, go talk to customer support, et cetera. And it's kind of like I call it like a catch-all. Some people do have like if they're not sure, et cetera, they'll have like a default path so it's kind of one variant of like, call it a catch-all. I think it really depends on your application. If it's something that's, you think that like the core goal, like the KPI that you're really trying to get back is ultimately you want to get people to buy products, which is in this case, it's a chat to purchase type of application. It's kind of up to you on like what you think the default experience should be. It's also, I think some of the advantages of some of the function calling stuff we were talking about beforehand in the routers using function calling, you can do extract out what the user's parameters were. Can you determine if there's a path that you can go down or multiple parallel paths that you can go down that might be able to get back an answer for the user? Lay's follow-up question is, because of the non-determinism nature of LLM, I'm wondering how the accuracy of the LLM intent classification is. Yeah, great question. I mean, I think this is another reason we'll talk about this in the next section, actually, about evals for routers. That's actually a great transition. Let's just go into that. Okay, so evals for routers. So, Lay, exactly your question of like, well, what if the intent classification gets it wrong? Well, first off, you should be using evaluations on your router. So regardless of whether you're doing both function calling or you're doing more classification types of metrics, if you get your router function wrong, basically you're probably not going to give the right response because you just sent the user on a path they didn't ask for. What we're seeing a lot of people in the ecosystem do is actually build out, kind of call it these classification metrics on the accuracy of the router itself. So they're actually evaluating how good the router is. And they can do this in a couple different ways. One is, by and large, the most common is they're using things like LLM as a judge to do this. So you have LLM as a judge, or they're, and for folks not familiar, you're with LLM as a judge, you're using AI to evaluate AI. So you have another call to basically evaluate, hey, this was the user intent, this is what we said the label was, out of these 10 labels, did it get the classification correct? And so they have some kind of ongoing way of um, you know, measuring that output and then measuring basically how good that response was. There is also human labeling that goes on where they do some degree of like spot checking on these, so that they make sure that they're consistently updating their LLM as a judge. If you're using LLM as a judge, definitely benchmark it. There's a whole bunch of content and material that webinars we've done on this specifically. So I'm not going to get into the nuances of like, why doesn't that work or where doesn't that work? Maybe in depth for this call, but there's a lot of material on this that we can hop into. Another path, so kind of the two paths here, you need some kind of classification metrics to be able to distinguish, did it get the intent correct? And then user feedback's another common one, which is also what we see people using in the market. If you're using one more, if you just go to the next slide down, which is if you're using the function calling approach for routers. So in this case, it's this router has two execution branches, a code generation one and a search for an item. And clearly it went down the wrong path. It went down the search for an item path. In this case, the function calling might also, you're evaluating not just the intent component, but you can also evaluate, well, did it call the function correctly? Did it call the APIs? Did it get all the extracted inputs to be able to use in the function call? And so there's all sorts of other nuances of function calling evaluations to look at as well. But just in the context of evaluating routers, the key thing takeaway, if you get anything, is like, you want to get the intent right, because it might mess up your whole path down. Dat, anything else to add there?
Yeah, I think it's a really good summary on it. And I think yeah, I think LM as a judge is, if you haven't heard of it, please check out our material, and it is pretty much ubiquitously used in the industry. So realizing it can scale out into data that maybe you don't need to label. LLMs are very good at catching kind of their own mistakes. I would say this is something, if this is kind of a new subject to you, just realize that it works, right? This is what companies do with the LLMs in production today. Like I'm sure you've interacted possibly with one of these architectures, you just didn't kind of know it. Um, and so maybe we go kind of into this one. I think, Aparna, I think you're going to cover this one, right?
Yep. So, okay, so now we've covered router functions, which is the first, prerequisite. You know what path you're going down. So there's a lot of different names for this that you might hear in the ecosystem, but once you're determining what the intent of the user is, there's different execution branches. People call it skills, people call it paths, however you want to call it, but it's essentially, it's the entire flow post determining the intent. And like I was saying with function calling, you might parallelize these. So if somebody's asking for, like in the previous question, it was actually really tough, to be honest, products with discounts in them, then you might do both the product search and you might do discounts and deals. And you want to look across both and see, how to both have, both connect. In a lot of the more internal, product co-pilot type of applications we're seeing, they might go down two different paths of how, how to get data. So I want to get data from this stream, I want to get data from this stream, and then I want to combine them together ultimately to make some decision. And so these execution branches, there's a decision here of, do you want only one path or do you want multiple paths? what we're seeing probably more common right now is folks starting off with one execution branch. Like in this case over here, they're all pretty distinct. I if a user asks to return a package or to track a package or something, then I'll just say track a package, then it's pretty distinct from help me find a new product. So in that case, you might not go down multiple paths, but this is definitely one where it's with function calling, you could do it.
Yeah.
Um,
Yeah, one thing to add here, just a consideration. So while this flow very looks like a do this, then that, then this, Aparna made a really good point. I think when you're optimizing these architectures, parallelize where you can. Just because the branch looks like, hey, do this, then do that, do that. That's not really how it's executed. Sometimes if like, imagine there's two API calls here next to each other. You can use things like state machines, like, hey, grab the condition of, all of these data pieces, etc and then do a call or make a decision or do some action. So just because, this particular diagram looks like a kind of like a graph where you do this and that, it's not actually maybe how it's executed. So what you really want to optimize for is latency for your user. If you have to do 5 steps and the user has to wait, 2 minutes, it's 2 minutes that they can, have time to kind of leave your platform or get distracted. So just realize that when we talk about these things, maybe how it's executed in code might look a little bit different, but just wanted to highlight Aparna's point of taking advantage of working with computers and serializing items. So go ahead,
yeah,
Aparna.
no, yeah, great point. Chris, actually, let me just take a couple questions from the chat. Chris asks, is there a disadvantage to parallelizing the calls? I mean, it might be, it just depends on your application. In some cases where you might need data from both streams, both different execution branches, you might want to do it so that you can parallelize it, get both the data instead of like waiting for it for one and then waiting for another. So it could end up being lower latency overall for your entire application. And so I think it does come back to your system and how you want to architect it. I do think that there's there's so many different components of that. Like how many components are in each of your execution branch and how many steps are they all, 2 turns, 3 turns? Are they all pretty far off? So I think it depends.
Yeah,
Uh,
and to add to that question, yeah, it also depends on dependencies, right? If you need one piece of data to get another, well, obviously you probably can't parallelize that super well. But yeah, the answer is depends.
yeah. Sorry, Chris. Probably an unsatisfying answer. Okay, so but hopefully we gave you questions to think about. So okay, so there's an execution branch. So what do people care about when they evaluate this? So what we've noticed is that these end up coming back to each execution branch will probably have its own set of KPIs. So in this case, if it's something like product search, what people care about is do they ultimately check out and buy the dang product? Because that's what ultimately matters. If you ranked the products correctly, you showed them what mattered. And so that's a different KPI than something like customer support, where chatting with a live support agent is expensive. So however much I can try to optimize and answer the question using RAG and the documents that I already do have, that's better. So there's slightly different, call it product KPI metrics that you might be looking at for each one of these skills. So if you go to the next slide, actually, that evals on the execution branch, um, it really comes down to it's tied in some ways back to the end-to-end eval. Did the user ultimately get their question answered? But specifically, I think it's better to, instead of just the overall positive experience of the user across all these different execution branches, this is a really good way to slice and dice your application and say, we're doing great on customer support, but we're not doing great on this. Right. So it's a great segmentation lever. User feedback across all these would be awesome. Okay, let's go to the next set here.
Awesome. And so we covered kind of the router kind of function, like the intent. Hey, do I want to go here or here? Then we covered each individual branch. What we're also seeing in the industry in the space is like it's the same idea. Like, how do you break down a complex problem where you break it down into little bite-sized pieces? And so the way I think of these components, similar to how you write like really good functions, a really good function or really good code, or a service even does one thing and one thing well, right? And so you have like a myriad of different types of components in here, and you might reuse them for some things. And so again, same exact idea. Each component will have its own eval set. So it turns out, your LLM call components, if they're going from unstructured to structured, how clean is it? Can you use an LLM as a judge here? Maybe you're calling internal APIs. Maybe it's a database. Maybe what we see is like, remember all those legacy ML like models that we used to work on 2 years ago, like ranking models, classification, regression, classic ML, if you will. It's not like people are abandoning those. Some companies have spent many decades, building really great, whatever, ranking models for flights or content rankers or items to buy. They haven't abandoned those. What they've actually done is just integrated them into these router architectures, meaning, hey, actually, if I'm going to go, present a product for you to buy, I'm actually going to call my ranking system that I know is really good and it's supported my business for the last 10 years. And so what do those evals look like? Well, those will look like, hey, does this component produce a really good, if it's a ranking model, NDCG, right? Based off of the customer's intent. What did they want to buy, right? And so while it is an NDCG or like a ranking metric, it's a ranking metric relative to this routing system. So they are interconnected. There's also other components, right? Some people just have natural heuristics. Maybe they want to send a user to the UI or want to be able to do XYZ or gather more information. The TLDR, long story short, here is that each individual component or building block that you build, um, if it's very crucial, obviously like the routing function, it should definitely have some set of evals. But again, as each of these components becomes better and better at doing their job, the whole entire experience that your customer is gonna, have is also gonna get better. So turns out each of these components, what we see in the industry and with folks in production is that they actually have an eval set for each of these types of components. And again, it's very business specific to your domain and what you're building, but you kind of get the idea that, yeah, if I fix the components that make up this big complex thing, the big complex thing tends to get better over time.
Yep.
Awesome.
And maybe the one just like quick add to this one is that um, components themselves, um, we're seeing a pretty big, I guess, like variance across different types of components. Um, People are, I think, still using ML to do some stuff like the ranking and the search and things like that they've definitely optimized. Um, but trying to use LLMs in as many places as possible. This, so it doesn't have to be just because we're saying router-based architectures doesn't mean that every single component has to be LLM. We're actually seeing, you know, people mix and match what makes sense for them.
Yeah, that's a really great point. And it actually, I'd take the opposite stance of like try not like use an LM call where necessary, and then use the other parts that are kind of proven. I think LLM calls are really good in certain situations, but sometimes we try to use them kind of everywhere because they're new and they're hot. But really great point. So now that we got a good sense of the different types of components, maybe we go into the real kind of nitty-gritty of maybe the types of evals we'll want to run. So when we think about LLM components, kind of similar to the router, but it's very contextual to what the LLM call is doing. So let's say if you're doing an LLM call and it's a RAG-based kind of task. Um, well, maybe you want to measure, hey, am I injecting the right things in terms of my RAG context to help answer the question? Um, in terms of maybe summarizations, if you've ever had to do a summarization, what people would like to measure in summarization is like, okay, like am I truly summarizing or is the output the same length as the input? Did I maintain the correct or relevant pieces of information in the summary, right? Am I missing anything that was very crucial? Um, Again, these LLM evals, what people tend to use in order to measure them is, LLM as a judge, super useful. Again, contextual to the LLM component that you're using. Of course, there's feedback kind of throughout. Um, but really what we see is for the LLM pieces, LLM as a judge is pretty crucial in measuring. And again, there's a whole other section in We've had previous talks on how to use LLM as a judge on different LLM kind of tasks. Cool. Um, yeah, here we go.
And oh, great. So there's kind of the LLM components. Like we said, a lot of these could also be function calls. There's actually a really great paper, Gorilla LLM, which we'll link actually in the chat. This is actually a leaderboard that they put up, and it's linked in the paper, which is basically just showing all these different foundational models and how good are they at actually function calling. Um, and there's a lot of different metrics that's discussed in this paper. Core is things like, did it get the intent? Did it extract all of the inputs? Did it format the API call correctly? And so there's kind of a lot that is tested. And then they've kind of set up this leaderboard to see which foundational models do function calling the best. The function calling can be used for a lot of different things. It can be used for your own internal calls. It can obviously be used for um, external calls that you need to make as well. But it doesn't have to be in, it doesn't have to be kind of just I use it just to structure the API call. It's also kind of doing some work to do the generation itself, like we mentioned beforehand. So function calls can be components. It can call out to basically your internal ML applications, and we're seeing this a lot. So just wanted to note that.
Awesome. And then again, yeah, to segue into non-LLM components, whether they're function calls or tooling calls, hey, did I call this API correctly? Is my input into my ranking API, into my legacy ML model correct? When you think about the evals for non-LLM components, let's talk about the first type of component, which is maybe tooling or internal APIs, or even hitting a data like a database or to grab more information. Um, Maybe some things to measure are kind of what we normally measure in normal like software. It's like, hey, did we have a successful API request? If we didn't, maybe we track that. Um, Again, we mentioned this earlier, but if it is like maybe an ML component, um, can we bring those metrics in, if it's of a classification or regression or a ranking model or whatever it is, those same, you can think old school metrics for classic ML can be used as the eval for that particular component, right? If that component is calling a classic ML model. And so these kind of make sense, right? It's kind of what we've been doing. Other components, this one really varies. It really depends on what that individual component is doing. So if you simply want to just rank the products, right, based off of a similarity, for instance, what you could do is measure, hey, what did people click on, for example? Did someone click at all? Not even that. Like, did someone click at all? Yes or no? And that's something your system can definitely track. Did we pull up the UI? Did the UI load with the right kind of items in it? This one's pretty straightforward, but again, it's really contextual. But maybe since these are more explicit, maybe you don't really need to add an eval to them since it's kind of just like software code running. So that would be my take on this.
Cool. In the interest of time, because we got about a minute, I want to make sure we hit a couple more things. And Ravi, Ravi Teja, your questions covered in the last slide actually. So let's get to it. So there's one, we've been talking all about evals for a router, evals across an execution branch or skill, and then each individual component. There's also at a high level looking at an end-to-end flow. Overall, how is this entire kind of, if this is kind of a full chatbot, how is this overall chatbot kind of doing? And so you can have metrics across each. I think it's important to have like a top level kind of aggregate view. It could be something simple like revenue, customer satisfaction, et cetera, engagement, things like that. Um, these are just some example ones we see. A lot of teams use revenue as a way to think about overall how is it contributing, and then they then slice and dice and segment it by all these different kind of execution branch, the intents, the components that we've been talking about to really actually improve it. So at a high level, it's good to have an end-to-end metric. There's one last topic, which I think we just wanted to introduce, it's kind of a slightly more advanced router architecture we're starting to see. And so we just wanted to like touch on it and kind of put the hint out, but there's probably a whole webinar we could do just on this, which is where do you save state in this type of architecture? Because you can go down one path. And Ravi Teja, in your question of like if you're making multiple function calls and you have information that you've actually gleaned, like extracted inputs or the inputs that you want to use in functions, and you then want to go save it off to go use in another path, there's absolutely a spot for where all of the state and context that you're building as you're going down this path needs to get saved. Some of the common ones we see is like, I've generated some code or template. Where do I go save that? I have some top search result, and now I want to use that in some other path for things like a discount on it. I want to save off, what's important from my user. And so all of these are important context you've built, and you might want to use that state in one skill based off of the results from another skill. And this is, this is, I think, and again, there's a lot of depth of like, how do you save it? Where do you use it? What kind of state is important? That really does become dependent on your application. But there's, there is a kind of stateless approach to this and a stateful approach to this. And depending on your application, like in Ravi Teja, your question of like, if you're trying to make series of calls that depend on the results of others, so you're not totally parallelizing maybe all of it, you're probably more looking for a stateful type of application. Okay, well, in the interest of time, I feel like thank you everyone for sticking through that and sticking through some pretty, I think, interesting content. If you take anything away, I feel like it's routers are becoming super popular. We think of them as like V0 agents. We're seeing a lot of people build on top of this. And how you evaluate, I think there's a really mindful approach of not just doing one end to end, but kind of thinking about these as different components and execution branches and thinking about that as you're building it. Awesome. Thank you, everyone.
Awesome. Cheers. Bye.
See y'all.